Here we will be solving the following rational expression. We are going to use two different methods. We're going to be using, I'm going to just refer to it as method 1. And in this method, we are going to be multiplying the left and the right hand side by the lowest common denominator. Now here, our lowest common denominator is going to be actually, before we do that, we need to factor this here, right? So let's just step back a little bit and do that quickly here. So we're going to get 2x minus 1 over x minus x plus 1 divided by x plus 4. And we can factor out the GCF in the denominator over there, which gives us x in brackets x plus 4. And this will allow us to determine the lowest common denominator being x times x plus 4. Now what we're going to do here in this method is that we're going to be multiplying each term. There are three terms, first, second, and then the third term is on the right hand side. We're going to be multiplying each term by the lowest common denominator. What that will allow us to do is it will allow us to eliminate the quotients, eliminate the denominators, which is going to simplify things when it comes to solving this. So let's start by multiplying the leftmost term by the LCD times, so this is your lowest common denominator, times 2x minus 1 over x. We multiply the second term by the LCD. And the same thing on the right hand side. Now what we're able to do is we can cancel the denominators. This x cancels against this x. This x plus 4 cancels against this x plus 4. And this entire denominator cancels against the LCD here. And now let's write out what we're left with. So from the first term, we're going to be left with two binomials. And from the second term, we're left with x times x plus 1. And from the right-hand side, the term on the right-hand side, we're left with 5x plus 8. And now, all we really have to do now is rearrange the terms. Well, expand it first of all. Expand the binomials here, rearrange the terms on one side, and then solve it for x. So here we're just going to use FOIL. We're going to get 2x squared minus x plus 8x minus 4. Distributive property for the second term, negative x squared minus x equals, so actually at this point I'm going to move these two terms directly over to the left hand side. So there's not going to be an equal sign here just yet. Instead it's going to say minus 5x minus 8 equals to 0. And now we can combine like terms. So we have two x squared terms that we can combine, which leaves us with just x squared. And then we have a number of x terms. We have negative x plus x, so 8x, that's 7x, minus x, 6x, minus 5x will just leave us with a single x. So we're done with the x terms. And then we just have negative 4 minus 8, which is negative 12. This is a trinomial. We can factor this. We're looking for two numbers whose sum is going to be 1, and product is going to be negative 12. Those two numbers are going to be 4 and negative 3. 4 plus negative 3 is 1. 4 times negative 3 is negative 12. And now we can just use the zero product theorem to determine the roots. X is going to be 3 and negative 4. Now, before we are done here, we need to be careful, because the minute we're dealing with rational expressions, so when we have the variable in the denominator, we will have non-permissible values. So sometimes we might want to find them at the outset before we start. That's perfectly fine. I often like to look for or determine what the non-permissible values are at the end. So I'm going to add them here. So x cannot be any value that would make any of the denominators 0. So clearly x cannot equal to 0. Over here, x cannot equal to negative 4. Okay, and if we look at this expression here, if we factor it, if we look at it this way, this is the same expression. We can again see that x cannot be 0, x cannot be negative 4. And then we sort of go through the rest of our work here, focusing on any situation where we have the x and x in the denominator to check that there are no other non-permissible values. And there are no other. There are two non-permissible values, 0 and negative 4. And as it turns out, negative 4 is one of the roots. So negative 4 cannot be one of the roots. So actually what we're going to do here is we're going to write that x equals to 3 and x cannot equal to negative 4 because it is a non-permissible value. So this is method 1. I'm going to look at method 2 as well. So first I'm going to erase here this work that I just did. There is probably a faster way of doing this. So in method 2, what we're going to do is we still need the lowest common denominator, which we already have. But this time, we're going to be combining the various quotients using the lowest common denominator. So this is, we can refer to that as method 2. So here we're going to be combining quotients or fractions using the lowest common denominator. Okay, so this is essentially exactly what we're doing when we're adding or subtracting fractions. We determine what the lowest common denominator is, then we multiply the denominators and the numerators by a factor that will give us that lowest common denominator. Okay, so our lowest common denominator is x times x plus 4. And the first term only has x in the denominator. So to get x bracket x plus 4, we need to multiply denominator and numerator by x plus 4. For the second term, in the denominator we have x plus 4, so we need to multiply it by x this time to get the LCD, which means we have to multiply the numerator by x as well. And then the third term already has the LCD, so we don't have to do anything there. So what this will allow us to do is it allows us to put on the left-hand side here, it allows us to put these two terms on a common division line. So it's going to be one division line. The denominator is x times x plus 4. And the numerator is the following expression. That's the numerator from the first term. This is the numerator from the second one. Now, what we're going to do here is we're going to expand the numerator and then combine like terms and simplify it. So, denominator, we're going to keep factored form. FOIL, so it's going to be 2x squared plus 8x minus x minus 4. Distributive property, negative x squared, not plus, negative x. That's the left-hand side. Right-hand side stays the same for now. Right. We can now combine like terms over here in the numerator. So I'm going to continue my work all the way up here. Okay, we have 2x squared terms. So 2x squared minus x squared just leaves us with x squared. We have 8x minus x is 7x, minus x is 6x. And finally we have a negative 4. And the denominator is just the LCD. And the right-hand side stays the same for now. Okay. In the next step, I'm going to subtract the entire right-hand side from both sides. Essentially, we're going to move everything over to the left so that it equals to 0. Now, the denominators are the same. And as I subtract this quotient from the right-hand side, I'm going to subtract it from the left-hand side. But at the same time, I'm going to put this on a common division line since the denominators are the same. So on the left-hand side numerator, we're going to get x squared plus 6x minus 4 minus, and we want to put this in brackets, so we want to be careful here, minus 5x plus 8. That's what we're subtracting. Denominator is just the LCD. Like that. Now we can drop this bracket, and of course when we drop this bracket, because there's a minus sign in front of it, the signs inside of it will switch. Like that. we can see that we can combine some like terms in the numerator. We have an x squared term. Then we have 6x minus 5x, that's x. And then we have negative 4 minus 8, that's negative 12. All right. We can now factor this, the numerator here. This is a trinomial that we can factor using the method of inspection. We're looking for two numbers that add to 1 and multiply to negative 12. Okay, those two numbers will be 4 and negative 3. So we can factor the numerator as x plus 4 times x minus 3 divided by the LCD. And now we see that this x plus 4 cancels this x plus 4. So we're just left with x minus 3 over x equals to 0. Okay, now we're solving this and we're ending up with a fraction. And this fraction here is supposed to equal to 0, which will only happen when the numerator is equal to 0. Okay, the denominator cannot be 0, right? So what we can do here is we can take the numerator, we can pull it out, and we're going to say that this left-hand side will equal to 0 when x minus 3 equals to 0, which will happen when x equals positive 3. And here we can, if you take a look at the denominator, we can see that we have an x in the denominator, which means that our non-permissible value here would be that x cannot equal 0, which we know, which we already determined that up here.